Hi there, this is an Algebra 1 video. It is Chapter 5, Section 5, and today we are talking about inequalities involving absolute value. And first thing I want to do is remind you of what it means to be, what absolute value actually means. And so basically we'll start with an equation, even though today we're talking about inequalities. I want to start with equations to remind you that an equation that says something like the absolute value of x equals 3, if you were to solve this equation means that they're looking for numbers, the x, where the distance between x and 0 is 3. So we know that there's actually two places, two numbers that are actually a distance of 3 from 0. We have 1, 2, 3, so if you're at 0.3, or if you're at 1, 2, 3, negative 3 on the number line, then either of those numbers, so the solutions for this equation will be x equals negative 3 and positive 3, because there are two numbers that have a distance from 0 of 3 units. Alright, so because distance is not negative, that's why we use the absolute value bars, because even though this is negative 3, how far is it from 0? 3 units. Okay, so now then what does that mean for inequalities? We have two of them here, and I'm going to use the same number line, but it says here the absolute value of x is less than 3 would then mean that you're looking for the distance between x and 0 to be less than 3. So for example, any number between 0 and 3, this would be where it actually equals 3, but any number in this range would qualify. So for example, the answer could be 1, because 1 is less than 3 units away from 0. 2 is less than 3 units away from 0. 2.5 is less than 3 units away from 0. 0.1 is less than 3 units away from 0. So now you have a whole slew of options. But basically, it'll be any number that is less than 3, and any number that is greater than negative 3 will satisfy this situation. So basically that's a compound inequality that you can actually write as a sandwich, which would be x is less than 3 but greater than negative 3. And this would be your solution in that case. And then of course, what if you're looking at, let's pick a different color here. What if you're looking at greater than 3? Well, now you want the distance between x and 0 to be greater than 3. So that would now include all of this area over here and this area over there. For example, the number 4 would be more than 3 units away from 0. The number negative 4 would be more than 3 units away from 0. But now if you want to write that compound inequality, now you're looking at x greater than 3 or x less than negative 3. And unfortunately, this one you can't write as a sandwich. So that's kind of what we're going to be dealing with today. We're going to do them, first we're going to hit the less thans, and then we'll get to the greater thans. But that's the idea. And the one thing that you should be noticing about all of these is that you're always going to have this two-pronged situation where you have positive and negative. You know, positive 3, negative 3, they all have that going on. So before we get started, I wanted to tell you that when you're solving absolute value inequalities, there are basically two cases that you must consider. And unfortunately, a lot of times people get questions on the quiz, for example, or on the test wrong because they fail to do the two cases. For example, I might make each question 6 points because I give you 3 points for the positive case and 3 points for the negative case, and then a student will only do one of the cases, so they're going to get half the points. So please don't do that. Just remember that anytime you have absolute value bars and you're solving an inequality, you have to have two cases. Okay, so the first case is what we call the non-negative case. And a lot of times you think non-negative means positive, but no, it actually includes positive and 0, because 0 is neither negative or positive. So you can't say positives, you just want to say non-negative, which includes the positive and 0. Case 2 is the negative case. And so basically in case 1, we want the expression that is inside the absolute value symbol, so basically in this case m plus 2, to be greater than or equal to 0. And in the negative case, you want the expression inside the absolute value symbol to be less than 0. Okay, so you always have to do 2 cases. So I'm going to show you what that looks like by solving these 2. So first of all, in my positive case, I'm going to just leave everything the same. M plus 2 less than 11. Notice that I no longer have the bars, and I'm just going to solve. So M is less than 11 minus 2 is 9. And that's my answer for the positive case. And then in my negative case, I'm going to put a negative in front of the expression that's inside the absolute value bars. So negative M plus 2 less than 11. I'm not changing the symbol or anything like that. Some people do that, and the reason why they do that is because of this negative here. If you would like, it would also be the same thing as dividing by negative 1. And then when you divide by negative, we all know that it now becomes a greater than, and it's negative 11. So if you're more comfortable doing that, that's fine. But I just leave it less than 11 and then distribute by negative and whatnot. So now I solve and I get that M is greater than negative 13. Okay, so then to graph my solution set, I'm going to have to get creative here. I don't have a lot of space. Have my variable. Going to put my 0 here. We have 9 and we have negative 13. Notice that the distance from 0 to 9 is shorter than the distance from 0 to 13 because 13 is bigger. And then as far as my solution, I want greater than negative 13, so I'm going to have an open dot and shade this way. But I also want M less than 9, so open dot and shade this way. And because this is an and, it's a less than. Absolute values that are less than are always going to be ands. And so I get everything that's in between negative 13 and 9. Alrighty, so I don't believe you have to write it as a solution set. But if we did, it would just be, this is an M, and it would be less than 9, but greater than negative 13. And I'm sorry for the crowdedness, but your answer would be right here in black. All values of M such that M is between negative 13 and 9. All right, so now we're going to do that again. Positive case here is to just rewrite it without the bars. Add 1. Negative 2 plus 1 is negative 1, so y is less than negative 1. And then my negative case would be to put the negative in front of the y minus 1. And then if I divide by negative 1, I get y minus 1, flip the symbol to a greater than, negative over negative is positive, add 1, add 1, sorry for me going lopsided here, y greater than 3. Okay, so I want to show you how this is going to look. So this is y, and I have a 0, 3's over here, and negative 1's a little closer. And so what this is saying is that y's are less than negative 1. So here is less than negative 1, open. And then it's saying that y is greater than 3. Like that. And so it's telling us that we have this as a solution, but the problem with this is that this is supposed to be an and situation. Like I said before, you have a less than here, and less thans for absolute values are always supposed to be intersections like part A was, and this one's not. So if we try to see where do they both happen at the same time, they never happen at the same time. So the answer here is no solution, it's the empty set. And another indicator that was going to happen is the fact that it says the absolute value less than negative 2. The absolute value is always going to be positive, so a positive number is never going to be less than negative 2. So had we seen that beforehand, we could have just avoided all the work and just called it the empty set from the get-go. But anywho, that's how you do that. And so now I want you to try this do-it-yourself question, and then we will move on to this word problem. And I put here before the word problem a little formula that I hope will help you with these kinds of problems. They're very common. I believe I already gave this to you when we did absolute value equations, but just in case you don't remember, the absolute value of a variable, well, depending on what your variable is, minus the ideal in the problem or the center of the problem. Remember that absolute value is the distance from 0 because 0 is the center, but sometimes the center gets shifted. And so this is where the center number would go. And then you can either have less than, a greater than, or an equal to, depending on what the problem's asking for. And then tolerance. And tolerance is basically the distance from the center. This might make more sense when you actually read the problem, but here we go. It says, a recent survey showed that 65% of young adults watched online video clips. The margin of error was within 3 percentage points. Find the range of young adults who use video sharing sites. So basically, the center in this case is the 65. Okay, so the center would be 65. 65% is what the survey said that they got. But because it's a survey and people are human, they're also willing to have a margin of error. And that margin of error is within 3 points. So that means that it could be above or below 65 by 3 percentage points. Hence, that's the distance from the center. 65 is the middle, and you can be above that or below that, so then that puts 65 in the middle. So hence, 65 is the center, and the 3 is going to be the distance from the center. So all we have to do is pick a variable. So I guess we could pick x, subtract the center, which is 65, and they want to be within 3 percentage points. They don't want to be outside of 3 percentage points. So we want it to be less than or equal to 3. And that's pretty much it. That's the equation you want to write, and then to solve it. So it says, find the range of young adults who use video sharing sites with a solve for x. So we're going to go to our positive case, which is going to be x minus 65 less than or equal to 3. So we add 65, so we get that x is less than or equal to 68. In our negative case, we're going to do negative x minus 65 less than or equal to 3. We divide by negative 1. When you divide by negative, we have to flip over the symbol to a greater than, and now it's negative 3. We add 65, and x is greater than or equal to 62. So as a sandwich, the range of young adults would be less than or equal to 68, while still being bigger than or equal to 62. So all x is such that x is between 62 and 68. That would be our range. So now, I want you to try that with this example right here, and then we will move on to our last example, which is the OR, solving the OR case. So it says solve the absolute value of 3n plus 6 greater than or equal to 12, then graph the solution to that. So the only thing that's going to happen here is that this is a greater than, and when you have a greater than with absolute value, it's always going to be an OR case. So I'll show you how that's going to pan out. Positive means you take the expression inside the bars, 3n plus 6 greater than or equal to 12. So we subtract 6, get 3n greater than or equal to 12 minus 6 is 6. Divide by 3, that's a positive number, so no flipping symbols. And n is greater than or equal to 2. In our negative case, we're going to get negative 3n plus 6 greater than or equal to 12. And then you're going to divide by negative 1. So you get 3n plus 6 greater than or equal to negative 12. When I subtract 6 from both sides, I get, sorry, I forgot to flip my symbol. When I divide it by negative 1, this symbol should have changed to a less than, and negative 18. Divide by 3, and is less than or equal to negative 6 because 3 goes into 18 6 times. Okay, so now when we graph that solution, so it's gonna be an or, as I said earlier, so we're gonna have n. We're gonna have maybe 0, 2, and -6. And we want to be less than or equal to -6, so we'll have a closed dot, shade that way. And then n greater than or equal to 2, closed dot, and shade that way. So you're gonna have an or, so it's either going to be here or there. So x such that x is less than or equal to, sorry, I don't know why I put an x. It should be an n. My variable here is n. N such that n is less than or equal to -6, or n is greater than or equal to 2. That will be my set notation, my solution there. And there you go. So again, when you have absolute value with the greater than symbol, it's going to be an or. When you have absolute value with the less than symbol, it's going to be an and. So now you have 2 more to solve. Once you have completed these examples, then you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.